It's trigonometry word problem time. If you know how to do trigonometry, finding angles or sides using SOHCAHTOA, law of sines, or law of cosines, word problems are really not that challenging. As long as you draw your picture correctly, it should be a piece of cake. So, you don't have to draw extremely accurate pictures. However, you should at least draw enough information where you know exactly what's happening. So it says you are standing 50 feet from a tree. You don't need a beautiful tree, but draw a tree. So that way you can get an idea what's happening here. And it says that you are standing 50 feet from it. So here's you. You are a person. You are standing 50 feet away. So you're standing 50 feet away from the bottom. You're not going to float across the sky to just somehow be standing away from the top. And now it says that you are going to look up at an angle of elevation of 54 degrees. So, angle of elevation is always based on the horizontal. So this is going to be your 54-degree angle. It says how tall is the tree, so that is X over here. So you see you have your right triangle. You can use SOHCAHTOA because we're going to pretend that this tree is growing at a 90-degree angle up from the ground. So we have an opposite, we have an adjacent. So that means we are going to use the tangent of 54 degrees is equal to the opposite over the adjacent. So then, of course, you just need to use your calculator. 50 times the tangent of 54 degrees is going to tell you that the height of this tree is 68.8 feet. And that's it. The most important part about word problems is drawing an accurate enough picture for you to be able to set it up correctly. All right? Here's another one. You're standing on a 140-foot tall lighthouse, and you see a boat at a 13-degree angle of depression. So how far is the boat from the lighthouse? Okay, so again, you're going to need to draw yourself a lighthouse. And it doesn't have to be perfect, but it's got to be good enough for you to see that you're looking at a boat. And the boat, of course, is going to stay in the water. And again, you're looking at a 13-degree angle of depression. So once you draw your triangle, and you can draw a triangle right here, be very, very careful. The 13 does not go there. Do not put it there. Angle of elevation and angle of depression are always based on the horizontal line. So there is no horizontal line by the guy. Well, yes, there is. He actually is looking straight out. Angle of elevation and angle of depression are based on your original line of sight. And most of the time, you're looking straight out in front of you. So this is your 13-degree angle. So you can do one of two things. You can subtract that 13 degrees from 90 and place it at the top. Or you can remember alternate interior angles and call your 13-degree angle here down at the bottom. You know that the lighthouse is 140 feet tall, and you want to know how far the boat is from the lighthouse. So of course, boats are going to stay in the water, so the X goes down at the bottom. Now you're good to go again. You have a tangent of 13 degrees is equal to the opposite over the adjacent. So 140 divided by the tangent of 13 is going to tell you that that boat is 606.4 feet away from the lighthouse. All right? That's it. So I would like you to think about this one on your own. An 18-foot ladder rests against the house at a 23-degree angle with the house. How high does it reach? Pause it, draw a picture, solve it, and then click play when you are ready to try and see if you got it correct. If you drew the picture correctly, the 23 should be where the ladder meets the house. The 18 is the length of the ladder, and X is your height. So it's the cosine of 23 is equal to X over 18. So 18 times the cosine of 23 is 16.6 feet. All right? So that's our first three word problems. And now we're going to go to the next one, and something funny is going to happen, and we're going to switch gears here. It says you're standing in a field 140 feet from a tree and 230 feet from a lake. And the angle between the tree and the lake are 105 degrees. How far is the lake from the tree? So now you have a little bit of an interesting situation here. So let's try to sketch this out a little bit better. We've got our tree and we've got our lake. And again, what it says is it says that you are standing 140 feet from the tree and 230 feet from the lake. And then it says that the angle between the tree and the lake is 105 degrees. How far is the lake from the tree? You see what's funny here? You don't have a right angle anywhere. You are going to have to use either the law of sines or the law of cosines to figure out the distance between the tree and the lake. That's why this question became a little bit different, is because we are no longer talking about a right triangle here. So luckily you have law of sines and law of cosines. So you know that we have the angle and we do not have the opposite side. So that's going to tell you that opposite side and angle, if you have both of them, you can use the law of sines. If you don't, you must use the law of cosines. But the nice thing about word problems is you usually only need to use the law of sines or cosines once, maybe twice, to get all your missing information. So here you go. X squared is equal to 140 squared plus 230 squared minus 2 times 140 times 230 times the cosine of your angle 105. And from here, you just have to use your calculator. Make sure you use your calculator correctly, and you will find out that the distance between the tree and the lake is 298.6 feet. Okay, so if you do not have a right triangle, if you have nothing that suggests a 90-degree angle, you must look into law of sines or the law of cosines. All right, one more problem. It says a farmer knows that his barn is 243 feet from an oak tree, and the angle between his barn and a pond is 83 degrees. The angle between the oak and the pond is 47. What is the distance from the pond to the oak and the barn? So this one you're going to have to find multiple pieces. It says what is the distance from the pond to the oak and the barn. So you're going to need to draw a nice diagram. So we're going to have our tree again, and you're going to have a lake again, and you are also going to have a barn. So here's your triangle. And now you should go back and read everything again. It says the farmer knows that his barn is 143 degrees from an oak tree. So here is your 143. I mean feet, not degrees. And then it says that the angle between his barn and the pond is 83. So your 83 goes over here. Okay, it's the angle that makes up the distance between the barn and the lake. And he says that he also knows that the angle between the oak and the pond is 47 degrees. So that's this guy right here. And you need to find the distance from the pond to the oak. That would make this one of the distances you need. And you also need to know how far the pond is from the barn. So you have two jobs to do. But luckily you know triangles always add up to 180 degrees. So you know that this angle down here is 50. And that's pretty much all you need. Look, you have a big and little. So you have the sine of 50 and 143. So you can use the law of sines on this one. So you have the sine of 50 over 143 is equal to the sine of 47 over x. And you get to use that exact same setup, the sine of 50 over 143. But now you're going to set that equal to the sine of 83 over y. And you just have to use the law of sines 2 times with your calculator. So 143 times the sine of 47 divided by the sine of 50 is going to give you that x is equal to 136.5 feet. And 143 times the sine of 83 divided by the sine of 50 is going to tell you that the distance between the barn and the lake is 185.3 feet. Okay, so again, there was nothing to suggest a right angle, so you've got to use the law of sines this time. All right, if you have a real good handle on law of sines, law of cosines, and SOHCAHTOA, again, the most important thing about these problems is setting them up correctly. If you draw it incorrectly for some reason, you're going to get the answer wrong, because it's not that you don't know your trig, it's you set up the wrong problem, so you set yourself up for failure in the first place. So make sure you read it twice, draw a picture, check it again before you start doing the math, and make sure your answers are logical. Okay? That's it. This is Longo, and I'm out. See you. Bye.